The red planet is no longer a distant, unchanging world. From Martian riverbeds hinting at ancient water flows to the colossal Valles Marineris telling secrets of fiery impacts, Mars constantly surprises us with new discoveries. But the burning question is, have we discovered liquid water on Mars? Let's address this question and have a look at some of the most recent groundbreaking discoveries made on Mars to date. Number 1. Water on Mars found. What do you think is the most important thing for colonizing Mars, or in fact, any place? Water for sure. So, have scientists found any evidence of water on Mars so far? It looks like they have. NASA's Perseverance rover made a striking discovery. In February 2021, the rover landed in Jezero Crater, a place believed by scientists to contain ancient water on Mars. So did the rover find anything? What the rover found wasn't liquid water or water bodies. Instead, it found evidence that water once existed on the red planet. There are several indicators, but most importantly, there are the clay minerals. These minerals form when water interacts with certain types of rocks. Additionally, the texture and shape of rocks found in this crater suggest they were shaped by flowing water. Lastly, the place where the rover landed, Jezero Crater, contains igneous rocks and not sedimentary rocks, as previously thought by scientists. Igneous rocks with salt-rimmed holes provide strong evidence that water indeed once existed on the Martian surface. Number 2. Evidence of lost civilization. Elon wants to colonize Mars by 2050, and his dedicated supporters are all geared up to take their flight to Mars soon. But what if I told you that Mars might have already been colonized by ancient civilizations in the past? On February 25, 2014, NASA's Curiosity rover sent high-resolution images of the Martian landscape to Earth, and what some archaeologists observed is beyond astonishing. They claim to have discovered an effigy resembling a human statue at the Dingo Gap, and that's not all. Other archaeologists have made similar claims in the past, observing several Earth-like objects in pictures received from Mars, such as a sarcophagus, a Buddha statue, and even a cross. So, what's NASA's take on this? Well, they dismiss the claims outright by labeling it as pareidolia, a phenomenon in which our minds perceive familiar patterns in things we see around us, like seeing shapes in clouds. So what do you think? Is it really pareidolia or evidence hinting toward a lost civilization? Number 3. Water flows on Mars. We have talked about the evidence of ancient water on Mars, but this is going to get crazy because scientists now believe that liquid water does exist on the red planet. See these images. We are looking at the middle southern latitudes, and right now, we have zoomed into the Newton Basin crater. Can you see these active features in the photos that look like running slopes? This area right here is a bedrock, a steep cliff most likely, and it's from this bedrock that these active features appear to flow out. So, what do you think these active features hint at? Well, given the latitude, the slope aspect, and most importantly the temperature, there's a strong likelihood that a volatile is involved here. And the most appropriate volatile to exist at this temperature is water. Isn't that crazy? And this is potentially actual running water expected to exist on Mars today, not some millions of years ago. So what do you think? Have we really found water on Mars? Number 4. Strange discovery in Gale crater. Do you know that the Curiosity rover has been working on Mars for the last 9 years, drilling 20 holes in the Martian rocks and coming up with intriguing discoveries every now and then? But this time, what Curiosity found is astounding. On February 13th, 2022, right before the drilling procedure, as the Curiosity rover was preparing the surface to analyze rocks, the rover captured these amazing photographs in which we can see this particular thing, an intriguing rock formation. Look at the shape of this rock. It's not typical, right? This particular rock formation caught the attention of many scientists right after the photos were released. What do you think? Is this really a rock formation? Or something other than that? Maybe it is something that our minds can't comprehend. Number 5. Mars moon, Phobos. What you are seeing on your screen right now are photographs of Phobos. Phobos is one of the two moons of Mars, the other one being Deimos. Several missions like Mariner 9, Viking 1, and Viking 2 have captured photos of Phobos. But the most detailed and clear photos have been provided by the Mars Reconnaissance Orbiter. So, what's so cool about Phobos? Well, Phobos orbits Mars at a distance of only 6,000 kilometers, making it the closest moon to its parent planet in the entire solar system. And would you believe that it takes Phobos only 7 hours and 39 minutes to complete its orbit around Mars? Yes, that's right. That is super fast. Some recent theories suggest that Phobos is slowly spiraling inward toward Mars, and some millions or even billions of years later, it will crash into Mars. What do you think would be the result of such a crash on the Martian surface? Number 6. Noctis Labyrinthus. Another quite intriguing place scientists have discovered on Mars is the Noctis Labyrinthus. What's with the name, by the way? Noctis Labyrinthus means labyrinth of the night. Yes, it's a complex network of valleys and canyons on Mars located on the western end of the Valles Marineris. So, for what feature did this labyrinthus catch our attention? Broadly speaking, for a lot of things like its maze-like pattern, its dangerous location, and its span stretching for many kilometers. But to be precise, its geological formation. Geologists believe that its formation is associated with some past tectonic activity that ended up creating this intricate system of deep, intersecting valleys. And that sounds reasonable as well, since it's located quite close to the Tharsis volcanic plateau. And here's more. According to scientists, erosion also played an important role in shaping these features that you can appreciate on your screen. And that just takes us back again to the idea of the existence of ancient water flows on Mars. Definitely another fact supporting the idea. Look at this magnificent mesa in the Noctis Labyrinthus. Isn't it spectacular? Number 7. Orcus Patera. Let's head on to a great Martian enigma, the Orcus Patera. Unlike many craters on the Martian surface that are round or oval in shape, this crater is an elongated depression stretching some 380 kilometers in length. And what's most intriguing about this crater is the fact that its origin is debatable. Some geologists believe that it was formed as a result of magma chamber collapse. Others believe that past tectonic activity could be its origin, with faulting and stretching within the Martian crust leading to its formation. Still, others believe that an oblique impact with a celestial body at an angle less than 5 degrees could have created this elongated depression on the Martian surface. And that's not the only enigmatic part about Orcus Patera. It tells a tale of 2 ages. The rough western part of this depression is thought to be over 3.5 billion years old, whereas the smooth eastern part is believed to be rather 500 million years old, hinting at some recent volcanic activity. So what do you think? What other mysteries does Orcus Patera holds? Number 8. Seasonal methane plumes. We know methane is a gas associated with some biological activity, and according to what we know so far about Mars, there's no evidence of biological activity on Mars. But what if I tell you that spacecraft orbiting Mars since 2004 have detected seasonal methane plumes in the Martian environment, rising in concentration in spring and summer? Isn't that astonishing? So what do you think these methane plumes are coming from? There are 2 possible explanations for that. It is a possibility that microorganisms residing deep within the Martian surface are producing methane as a result of the decomposition of organic matter in an oxygen-free environment. But it's nothing more than a big maybe. Another, yet more acceptable explanation for these methane plumes is geological processes. The complex interaction of water and rocks deep within the Martian bed might be releasing this methane into the Martian air. Do you think either of these can be a possibility, or could there be some other explanation? Number 9. Ancient organic molecules. One discovery after another prompts us to wonder, did life really exist on Mars billions of years ago? And here's just another example. scientists have found many pieces of evidence of ancient organic molecules existing on the Martian land. It all started with the study of Martian meteorites. In the 1990s, scientists like Dr. David McKay discovered evidence of organic molecules and possible microfossils within these meteorites. And then the rovers took over. In 2008, the Curiosity rover landed in Gale crater, analyzed rock samples, and detected various organic molecules, including complex hydrocarbons. And the most recent of all is the discovery made by the Perseverance rover mission, which discovered yet another diverse range of organic molecules in the Jezero crater rock samples in 2021. Some of these organic molecules include thiophanes, benzene, and propane, all of them found in sedimentary rocks over 3 billion years old. So what do these ancient organic molecules hint at? Was there life on Mars billions and billions of years ago? Number 10. Recurring slope linei, RSL. Another evidence of water on Mars? It looks like you're about to be convinced that there is water on Mars. Let's talk about RSLs. RSLs, short for recurring slope linei, are dark, narrow streaks formed on slanting surfaces such as Martian craters or hillsides. RSLs also exhibit seasonal variations. They appear in summer and disappear in winter. Now, why am I mentioning RSLs? And how are they related to water on Mars? According to a hypothesis, salts in Martian soil absorb water vapors and lead to a briny water eruption. This eruption manifests as RSLs on Martian craters. NASA's spacecraft, the Mars Reconnaissance Orbiter, MRO, is dedicated solely to studying these RSLs. Do you consider this a reasonable explanation for the existence of water on Mars? Number 11. North Polar Ice Cap of Mars. An ice cap approximately 2 kilometers in thickness exists at the North Pole of Mars called the North Polar Ice Cap. And no, it's not regular ice. It's a layered structure, much like a giant layered cake. With a diameter of 12,000 kilometers, the ice cap is composed of water ice with an outer covering of dry ice, carbon dioxide. This outer covering of carbon dioxide is seasonal in nature. During the winters, a large amount of carbon dioxide freezes out of the atmosphere, adding a layer of dry ice on top of this ice cap. During the summers, it changes back into gas, leaving the underlying ice cap exposed. Thus, this ice cap varies in thickness. Scientists believe that this layered structure is a result of the accumulation of dust and ice over millions and millions of years. And here's the interesting part. Some scientists even believe that this ice cap might be harboring vast amounts of liquid water beneath its layers. Will we ever be able to explore this ice cap in detail? Only time will tell. Number 12. First Marsquake discovered. Scientists had been living with the belief that only Earth can experience Earth tremors until 2019, when a discovery told them otherwise. On April 6, 2019, the InSight lander, a NASA mission, recorded the first confirmed seismic signal originating from within the planet. And for the first time, scientists had definitive proof that seismic activity can occur on planets other than Earth. This discovery has reignited research among scientists. They are now studying how seismic waves travel through the Martian surface and their potential strength. And that's important, especially for the future Mars venture. Without understanding the environment, how can humans be convinced to step onto this alien planet? But to be honest, there's not much need for worry, at least for now, because the seismic activity detected on Mars was quite weak compared to what happens on Earth. But still, would you risk going to Mars, considering how little we know about the Red Planet? Number 13. Ancient Mars River. This has to be the most convincing evidence of ancient water flows on Mars. I'm referring to the ancient Mars rivers. These valley networks etched onto the Martian surface suggest that they were once conduits for running water on Mars. Their resemblance to dried riverbeds on Earth is uncanny. And then these sedimentary deposits on the Martian surface further strengthen this idea. These layered rock formations contain rounded pebbles and cobbles, hinting at the action of flowing water. And all this became more of a fact when NASA's Perseverance rover made another astounding discovery: a delta in the Jezero crater. Deltas are fan-shaped deposits that form when rivers flow into larger bodies of water, and finding these on Mars is strong evidence of ancient water flows on Mars. What do you think happened to these riverbeds over the course of years? What caused them to dry up? Number 14. Valles Marineris. Mars might seem like just a quiet, dry land that appears all red to us. But there's much more to it. Mars boasts Valles Marineris, a large network of canyons on its surface. In fact, the largest canyon system in the solar system. Let me help you imagine how large it is. If this colossal canyon system were placed on Earth, it would stretch from Los Angeles to New York City. Reaching a depth of 10 kilometers and a width of 600 kilometers, Valles Marineris signals a much more violent and active geological past of Mars. Though its origin is also quite debatable, scientists believe some past violent tectonic activity led to its formation. Number 15. Filicsilicate Rocks. Another exciting discovery made on Mars is the filicilicates, a class of silicate minerals that share a sheet-like structure, somewhat similar to clay on Earth. And why is this discovery exciting? Well, these minerals form when water interacts with rocks rich in aluminium, magnesium, and iron, all indicating the likelihood that Mars once had liquid water on its surface for extended periods. Also, filicsilicate rocks are not found everywhere on Mars. They are concentrated in specific regions, particularly in the ancient Martian highlands, dating back to the Noachian era, around 3.7 billion years ago. These regions are thought to have been sites of ancient lakes and rivers, where the interaction of water with rocks led to the formation of these minerals. So, does the presence of filicsilicate rocks guarantee life ever existed on Mars? Well, yes, it does point towards a more habitable environment in the past, because these minerals not only require water for their formation, but they can also trap and preserve organic molecules, the building blocks of life. We are convinced that ancient water flows existed on Mars, but life on Mars? Well, we don't have solid proof for that yet. Number 16. Mega dust towers. We've seen the Eiffel Tower, the Leaning Tower of Pisa, and even the iconic Evola Tower. But Mars boasts its own unique spectacle: giant dust towers. Giant dust towers can be seen on Mars during specific times of the year. As tall as 80 kilometers and stretching across acres of Martian land, these dust towers are magnificent wonders of nature. But how do these towers actually form? At a specific time of the year, Mars experiences a global dust storm. These heavy winds lift dust particles into the air, leading to the formation of dust clouds. When enough dust is gathered, it attains the shape of giant, towering columns. These dust towers are particularly more common during the spring and summer of Mars. NASA's Mars Reconnaissance Orbiter, MRO, which has been orbiting Mars since 2006, revealed details of these dust towers that helped scientists evaluate the environmental conditions and habitability of Mars better. Number 17. Magnetic fields. On Mars. Mars, our red neighbor, is a world of contrasts, yet it lacks a global magnetic field like Earth's. Scientists believe Mars once had a strong magnetic field generated by a churning molten core billions of years ago. However, as the core cooled and solidified, the dynamo process ceased, leaving Mars vulnerable to the solar wind. So what did the solar winds do to the Martian surface? These solar winds wreaked havoc on Mars's thin atmosphere. Unlike Earth's magnetic field, which deflects these harmful particles, Mars is exposed. These solar winds might have played a role in stripping away water from Mars. Don't fool yourself into thinking that Mars was always the cold, dry desert we see today. Number 18. Mars is red due to rust. We have become so used to the name Red Planet, and that's because of how it appears to us. So what causes Mars to appear red? Mars owes its distinctive color to the abundance of iron oxide in its soil and rocks. Iron oxide, commonly known as rust, forms when iron reacts with oxygen in the planet's atmosphere. This chemical reaction gives Mars its rusty red hue, visible from Earth even with the naked eye. Interestingly, Mars isn't uniformly red everywhere. The planet's surface varies in shades of red, from dusty terrains to darker, more oxidized regions. And with rovers and orbiters currently exploring Mars, we might one day get to know the full story behind the red planet's rusty coat. Number 19. The Wars of the Worlds. In 1897, H.G. Wells's The War of the Worlds wasn't just science fiction. It was a cultural shock. The story, told in a chillingly realistic news report style, revolved around a Martian invasion of Earth. But this fictional story caused real panic in some communities. Newspapers sensationalized the story, and a 1938 radio adaptation led to brief moments of hysteria. Despite causing some panic, The War of the Worlds became a major influence on science fiction. It introduced the idea of alien invasions, inspiring many future sci-fi writers. Have you read this famous novel, by the way? Number 20, Atmospheric Loss. I have already mentioned the fact that Mars wasn't always this dry and barren. Mars has undergone significant atmospheric loss over billions of years, transforming from a once potentially more Earth-like environment to the cold, dry planet we observe today. One key factor is Mars's lack of a global magnetic field like Earth's, and we have already discussed how solar winds stripped Mars of its atmosphere. Another contributor to atmospheric loss on Mars is its lower gravity compared to Earth. Mars's gravity is about 1/3 that of Earth's, making it easier for lighter molecules to escape into space. Imagine how the red planet would appear to us with its atmosphere intact. Number 21. There are seasons on Mars. Mars might be our rusty red neighbor, but it's not stuck in a perpetual chill. Just like Earth, Mars experiences seasons, though they come with a twist. Martian seasons last almost twice as long as Earth's because the red planet has a longer year, nearly 687 Earth days. This means a Martian summer stretches on for about 7 Earth months, with autumns, winters, and springs following suit. Also, Mars's orbit isn't perfectly circular, it's more oval-shaped. This eccentricity means that some seasons are more extreme than others. Will future humans find a way to thrive on the red planet, even in these weather extremes? Number 22. Evidence of ice on Mars. Evidence of ice on Mars has been compelling, as we talked about the North Polar ice cap earlier. One of the most intriguing findings came from NASA's Phoenix lander, which in 2008 directly observed water ice near the planet's surface in the form of icy soil. Additionally, radar data from spacecraft like Mars Reconnaissance Orbiter and Mars Express have detected vast underground ice deposits, sometimes just a meter or two beneath the surface. These discoveries suggest that Mars is not entirely devoid of water. Does it really harbor significant reserves locked in ice? Maybe yes, maybe no. Number 23. Calcium-rich deposits. On Mars. NASA's Curiosity rover has made a fascinating discovery on Mars by identifying calcium-rich deposits in its Gale crater exploration site. Calcium sulfate, found in the form of veins and nodules, indicates past interactions between water and rock. These deposits are significant as they hint at environments where liquid water may have been present long enough to interact with the Martian crust, potentially providing habitats for microbial life. Number 24. Glass deposits on Mars 1. Notable discovery came from NASA's Mars Rover opportunity, which found tiny glass spheres, or spherules, in the Martian soil. These spherules, called blueberries due to their small size and bluish tint under certain lighting conditions, are thought to have formed from volcanic eruptions long ago. The presence of glass on Mars indicates past volcanic activity and impacts that could have altered the planet's surface environment. That's it for today. If you enjoyed what you saw, please hit the like button and subscribe to our channel for more fascinating content like this. Also, don't forget to hit the bell icon so you can tune into our next video right on time. Until next time.